Okay, so here is a video that will show you guys another example of finding definite integrals. So what we have here is something that's a little bit more complicated, right? Not only we have two trig functions, the one at the back even have a power, right? So this is a more complex example. Okay. But again, we are going to approach the definite integral pretty much the same way. Okay, so I'm going to think about what do I differentiate with respect to x so that I'll get this whole chunk here. Okay, all right. So go ahead, pause the video, and think about what do I put in the box here. Okay. All right. Let me remove the box. Okay. So now. So we can go with there are two possibilities. Actually, there are many possible stuff that we can put in there, but given what we have, um, in order for us to have a derivative that has a sign, so a possible one would be maybe something in terms of cosine here, right? Or my other choice would be, in order for me to get something that has a cosine, I must have something with a sign here. Right. So if you gave those two a thought, and that's it, that's good, right? But here I'm going to go with the one with the higher power. Okay, and you guys will see why. So here I'm going to say I'm going to differentiate cosine 2x to the power of 4. Okay, cosine 2x to the power of 4. Okay, if you're wondering how did I get that, don't worry about it. So let's just try to differentiate cosine 2x to the power of 4 with respect to x, and let's see what happens. Okay, so we have trig function, and we have power function, and then we have a linear function. All right, so now we should start off by doing the power function. Okay, and then we'll deal with the trig function later. Right, and then we'll finally deal with the the linear function. Okay, let's do that. So the first one is the power function, so I'll have the 4 at the bottom, and then 4 in the front, and then cosine of 2x, but not to the power of 4 anymore. It's actually power of 3, right? Power of 3, and then so I'm done. That's it. That's the power function, and then multiply by. So let me change a different color. Let me use blue. So the second one that we have to differentiate is the trig function, the cosine there. So if I differentiate cosine 2x, I will get negative sine 2x. 2x. Okay, and then finally I'm going to multiply that by last one, which is linear function, so that is just a 2. So if I clean that up, if I clean that whole thing up, I'll get negative 8 sine 2x. Okay, negative 8 sine 2x cosine cube. Cosine cube to cosine 2x cube. Okay. So now, for those of you who, some of you guys might see this already. Sine 2x, sine 2x, cosine cube 2x, cosine cube 2x. So the only problem right now is this negative 8. Right? The only thing that we do not want is negative 8. So when I differentiate cosine 2x to the power of 4, when I differentiate that with respect to x, I I get almost everything except the negative 8. Right, but I can take care of the negative 8 easily, right? So, which means the integral of that whole chunk is just negative. So in order for me to take care of the negative 8, I'll do negative 1 over 8, right? So that cancels out. And then sine 2x. Oh, wait. And then I'm going to put cosine 2x to the power 4. Right? And then I'll put down the definite, the lower bounds and the upper bounds. Pi over 4 and pi over 2. Okay. So I hope you guys are still following. This stuff quite a lot of thinking to do here, right? So when I differentiate, so ultimately I'm looking for something that when I differentiate, that something will give me this sine 2x cosine cube 2x. And so you can use this higher power, the trig function with the higher power. You can most of the time you can use that as a starting point. Okay, so since we know that this is power of 3, so to go up a level we should have a power of 4, right? So that's the reason why I put down the 4 there. Okay, so when I differentiate cosine 2x to the power of 4, that gives me something that is very, very close to what we wanted, right? Very close to what we have here. So apart from that negative 8, so I can take care of that negative 8 with this negative 8. I'm just going to use this negative 1 over 8 to take care of it, and everything else just goes in. Right? Everything else just goes in. Okay, so now this is the easy bit. This is the easy part. I'm just going to evaluate the value. So I'm going to put that negative 8 out, and then let's say, so you can use a unit circle again, right? So cosine 2x to the power 4, and we have pi over 2, so that gives us cosine pi. Cosine pi to the power, cosine pi is equal to negative 1. So negative 1 to the power 4 gives us 1. Right? If you're not following here, go ahead, write it down. So you can write this down. So you have cosine 2 times pi over 2, and this whole thing to the power of 4, right? Minus cosine of 2 multiply pi over 4, the whole thing to the power of 4, and close parenthesis. Right. So use your unit circle, you'll get 1 over 8 in the front, and this is, okay, get your unit circle now, right? So 2 and that 2 cuts out, so I have cosine pi. Cosine pi gives us negative 1, right? Negative 1 to the power of 4 gives us 1, minus this 2 and that 4 cuts out, so I have cosine of half pi. Cosine of half pi is equal to 0, right? So cosine of 0, cosine of half pi is equal to 0, so this is 0. 0 to the power of 4 is still 0, so my final answer would be negative 1 over 8. Okay, Yep, this example is a lot more complicated than the example I showed you guys in the previous video. Please do go replay and write down any questions that you have on any of the steps. Or you can refer to the textbook. In the textbook, they solved this definite integral using a different method. They used the substitution method. And go ahead, take a look. If you have any questions, write it down and we'll discuss about them in class. Alright, see ya.